What the Mars bleed valve actually does. Let's talk about the Mars bleed valve. On startup, this valve is your compressor's safety net. It takes air from the compressor casing and dumps it straight into the exhaust. Not for performance. For survival. In the early part of the start sequence, the front stages of the compressor are already moving a lot of air. The back stages are still inefficient. They can't process all that flow. If you don't get rid of the excess, the compressor will surge. And when a Mars surges, it doesn't cough, it hits hard. You're into blade and seal damage, and a very expensive repair. So during start, the bleed valve is not optional, it's the life support for the compressor. Why it matters in the field. Here's the trade-off. Every pound of air you dump overboard, is air that is not going through the turbine to make power. So yes, the bleed slows acceleration. Too much bleed and you have a hung start. Too little bleed and you have surge. That balance is the whole game. And when you're standing on the deck, watching a unit struggling to accelerate, this valve is one of the first suspects, because it directly controls compressor stability during the most vulnerable part of the start sequence. 4-inch versus 6-inch casing bleed. Now we get into configuration. The Mars can have a 4-inch or a 6-inch casing bleed. That is not a small detail to the control system. With a 6-inch bleed, the valve sits at 32% open below 60% corrected NGP, then ramps closed from 60% to 80%. With a 4-inch bleed, it sits at 50% open, then has the same closing ramp. Why the difference? Because the flow capacity is different. Bigger pipe, flows more air for the same valve position. If the control system is set for the wrong valve size, the machine will tell you very quickly, with the wrong logic for a 6-inch valve, there may not be enough bleed, and you risk surge. With the wrong logic for a 4-inch valve, there may be too much bleed, resulting in slow acceleration, and a hung start. That's not theory. That's real troubleshooting. Corrected speed, why the ramp uses it. The closing ramp is based on corrected NGP, not actual speed. That's temperature compensation. A unit running at 100% on a hot day, is not moving the same amount of air as the same unit on a standard day. Example. 100% NGP at 100 degrees Fahrenheit, is only about 96% NGP speed on a 59 degrees Fahrenheit day, in airflow terms. The compressor only cares about airflow. So the control system schedules the bleed using corrected speed. If you ignore that, when you're analyzing data, your conclusions will be wrong. The 90% open position. You may see the valve capable of going to 90% open. That is not a start condition, that is an overspeed protection response for the power turbine. Different scenario. Different logic. And on SoLunox machines, the bleed also plays a role in emissions control. So its position is not only about surge, it can be part of the combustion air management strategy. Old turbines versus Mars control philosophy. If you've worked on Centaurs or Saturns, you remember the old style. Bleed valves were open or closed, digital control and fixed speed references. Why did that work? Those turbine compressors had big surge margins, and were forgiving. The Mars is a high-performance compressor. High efficiency. Tight surge margin. It needs a modulating valve and a scheduled ramp. That's the price of performance. How the PEC actuator is calibrated. Now, the part that causes real site problems. The closed position calibration. This actuator references everything from the mechanical closed stop. So the procedure matters. Back off the closed stop bolt. After energizing the valve, inject a 4 mA signal into the actuator. This drives the valve to the mechanical seat with force. Then screw the stop bolt in, until it just touches the stop. That position becomes the zero reference for every other command. If that stop is wrong, every indicated position is wrong. And the control system will be doing perfect math on bad mechanical information. What the results mean in the field. So a quick bleed troubleshooting roundup. Hung start, check for too much bleed. Wrong size bleed. Bad calibration, valve not reaching its scheduled position. Signs of surge during acceleration? Not enough bleed. Position feedback looks correct but behavior is wrong? Closed stop calibration is suspect. And always ask one question. Is the control system configured for the actual hardware installed? Because if the software thinks it's a 4-inch valve, and the casing has a 6-inch, you will chase your tail for days. Experience-based takeaway. The Mars bleed valve is not just a start device. It is a surge protection system. An acceleration limiter. Part of emissions control. A calibrated critical actuator. Get it right, the machine starts clean and smooth. Get it wrong, and the symptoms will send you everywhere, except to the real issue. And that's why experienced technicians look at the bleed schedule early in a startup problem.